So just as plus undoes minus, and minus undoes plus, and divide undoes times, and times undoes divide, and squaring and square rooting are opposite functions, differentiation has an opposite as well, anti-differentiation. And the process works exactly like by understanding how it works, but then just doing it in reverse. But when we reverse it, there's something else that we need to take into account. So for example, if I, for example, have y equals x cubed plus 1 and y equals x cubed plus 2, and I take the derivative of both of these, what's my derivative function going to be? If I take dy dx of both sides, what am I actually going to end up with? If I take dy dx of both of these functions, what answer am I going to get? Yeah, I got someone in there. Yep. So they're both going to be 3x squared. That's a little curious. So two very similar original equations both have the same derivative because during the process that constant falls off the end. So that means that whenever we do an anti-differentiation and we reverse it, we have to be aware that there can be many answers that create the derivative. For example, I could do x cubed plus 3, x cubed plus 4, x cubed plus 5. They're all going to have the same derivative function. So if I were to then reverse it, I then have to keep in mind that there's going to be a constant on the end. And in most cases, I won't know what that constant is. So what we've got here is, so I'm going to write out, so I'm going to say dy dx is equal to 4x cubed. What function would create that derivative equation? Think about how we take the derivative and find the derivative in the first place and then reverse it. So what we do is we take the 3, drop it down the front, and then subtract 1 from the power. So, yep, I got someone in there with the correct answer. All right, so instead, we add 1 to the power and then divide by the new power. So it is in fact going to be x to the power of 4. But is that x to the 4 plus 1, or plus 2, or minus 1, or minus 2, or minus 3, or minus 4, or minus 5, or plus 5, plus 6, plus 7? We don't know. So in this example, where we don't have enough information to keep going, what we say is plus c. All right, so plus a constant. Whenever you're doing anti-differentiation, always assume that there is a constant on the end until you are given enough information to then eliminate that constant at the end. All right, so we can generalize the rule for how this works. So there's a little symbol here. This symbol means it's used in integration, but in our case, it just means you're taking the antidifferential of Not having a good day today. So you've got a function, you're taking the antidifferential with respect to x, and that is then going to equal n. So ax n minus 1, you figure out what n is. You're then going to go back to the original n and then divide by the original number, which is what happened when we did, so x to the 4, if we anti-differentiate that with respect to x, then we get x to the 4 plus 1, which is 5, and we divide by that number. So if we go into our CAS calculator, we can see how this works. So you can see here, we've got the symbols involved. So you can find these under Math 2, row 3, column 4. All right. These two boxes here, you do not need to put anything in. Those are for application tasks. We do not have to worry about those right now, but instead you type your equation and then you want to make sure that you're saying x. It assumes x otherwise. And then it gives you your answer. But there's a problem. There's a problem with how my CAS does it, and which is why you should never rely completely on your CAS, because it does sometimes leave important things out. So in my previous example, up the top here, I anti-differentiated 4x cubed and got x to the 4 plus c. Now my CAS will not put the plus c on for me. So this is something that you yourself have to get into a habit of doing, that whenever you're doing anti-differentiation, always remember plus c. Then usually you are given another piece of information to then work out what c is. So, as an example, if f dash x equals 3x squared, actually no, we'll do something a little easier for you guys to start with. If f dash x equals 2x plus 1 and f of 0 is 0, find f of x. So if f dash x is 2x plus 1 and f dash 0 is 0, if f of 0 is 0, find f of x. So you now have a derivative equation and you have a piece of information about the original equation that you can now try and solve. So what we need to do is we need to anti-differentiate. Keep getting those two words mixed up. We need to anti-differentiate 2x plus 1 with respect to dx. So what I need to do is I now need to add 1 to the power and divide by the original power. So this is x to the 1. So I need to make that x to the 2 and then divide by 2. So 2x to the 2 divided by 2. Now, whenever you see a constant like this in something that you are anti-differentiating, you have to remember that this is going to create a new x in your original function. So for example, what is the power of x right here? It's x to the 0. So I now need to add 1 to that power. And then divide by my power. Now that I have this, don't forget plus c, because you're doing a constant. You're trying to find the constant. Now I can cancel this down. 2 divided by 2 is 1. 1 divided by 1 is 1. I don't need to write that power up there. So I now have the integrated function of x squared plus x plus c. So if f dash x was 2x plus 1, then f of x is going to be x squared plus x plus c. I also now know, coming back to the original question, f of 0 is 0. So what I then need to do here is go, well, if f of 0 equals 0, then 0 equals 0 squared plus 0 plus c. Which means that I can then work out that c is supposed to be 0 as well. Only way that makes sense. And then I can, with confidence, say if f dash x equals 2x plus 1 and f of 0 is 0, then f of x is going to be equal to x squared plus x. No, you cannot. You cannot add those together because they do not have the same power. That's an x squared plus an x. They don't have the same power, so you cannot add them together. All right, so whenever you are anti-differentiating, the resulting thing is going to be 1 power higher than the original. So because we started with 2x plus 1, that means that my original function is going to be a squared, not a linear. All right. So remember, we cannot merge these two together because this is an x squared and this is an x to the 1. You can only gather like terms that have the same powers in them. So x squared, x to the 1 are not the same, so I can't do anything with those. So let's do another one. If f dash x is equal to 4x cubed plus 3x squared plus 2x plus 1, and f of 1 is equal to 5, find f of x. So we need to take the integral, or sorry, the antidifferential of 4x3 plus 3x squared plus 2x plus 1 with regards to x. So that's what we're differential. So you need to have this here and this here. So add 1 to the power. So here we add 1 to the power, divide by the new power. So that's 4x to the 4 divided by 4. Add 1 to the power, divide by the new power. So that's 3x to the 3 over 3. Add 1 to the power, so that's a 1 there, so we're going to make that a 2. Divide by the new power. This is x to the 0, so we're going to make it x to the 1. And then divide by the power. So that's going to be 1x to the 1 over 1. And then because dx plus c. Now, I can cancel all that down. That 4 goes away, that 4 goes away. That 3 goes away, that 3 goes away. That 2 goes away, that 2 goes away. That 1 goes away, that 1 goes away. That's a plus, by the way. So then, all I am left with is f of x equals x to the 4 plus x to the 3 plus x to the 2 plus x plus c. Now is when I bring in that other piece of information that I know. I know that f of 1 is 5. So I can now substitute in, if f of 1 equals 5, then 5 equals 1 to the 4 plus 1 to the 3 plus 1 to the 2 plus 1 plus c. Well, 1 to the 4 is 1, 1 to the 3 is 1, 1 to the 2 is 1, and 1. So it's 1 plus 1 plus 1 plus 1. So that means 5 equals 4 plus c. What does that mean c is equal to? C is equal to 5 minus 4. C is equal to 1. Therefore, I now know that my full original equation is going to be f of x equals x to the 4 plus x to the 3 plus x to the 2 plus x plus 1. That's going to be my original equation. So what happens if, so I've obviously been doing ones that are nice and neat and completely cancelled down. What happens if it doesn't? All right. So let's do one more, but this time the numbers aren't going to be nice and neat and cancel down and make everyone nice and happy. If f dash x is equal to 4x squared plus 9x minus 3, and f of 2 is equal to 8, find f of x. So if f dash x is 4x squared plus 9x minus 1, then what have we got here? So first things first, we need to do our anti-differential. 4x squared plus 9x minus 3 with respect to x. Add 1 to the power, divide by the original power. So that's going to become 4x cubed divided by 3. Add 1 to the power, so it makes it 2 divided by 2. So that's going to be 9x squared divided by 2. X to the 0, add 1 to the power, divide by the new power. So that's 1 to the 1. Plus c, because we always have to have a plus c. So my original f of x at the moment is that. All right, I can't do any cancelling down. Well, I can get rid of that. But I can't do anything else right now. So what I now need to do is use the other bit of information that I'm given. F of 2 is 8. And go, well, okay, eight equals, so f of 2, which means it's going to be 4, 2 cubed over 3 plus 9 minus 3, 2 plus c. So that means we're going to have 8 equals, so that's 2 cubed, so that's 8. So it's 4 times 8, so it's 32 over 3 plus 2 squared is 4. 9 times 4 is 36 over 2 minus 6 plus c. 36 over 2 cancels down to become 18. So 8 equals 32 over 3 plus 12 plus c. And then all I need to do is solve for c by subtracting 12 from both sides. So that's going to be minus 4 equals 32 over 3 plus c. And then I need to subtract 32 over 3 from both sides. Minus 4 minus 32 over 3 equals c. So the way this is going to work out is I need to convert this minus 4 to a fraction over 3. So that's going to be minus 12 over 3 minus 32 over 3. And that's therefore going to become, c is going to be equal to negative 44 over 3, which doesn't simplify down, but it's about 15. It's a little bit less than 15. That means that my original function, I can come back up to here and go, well, I can just rewrite it again, but replace that with minus 44 over 3. And my function, I have now created the original function. So there's a little bit of extra work when things don't nice and neatly cancel down, but you can do it. All right, so using our CAS to help us with this question, you still need to do a bit of work on paper, but you can also use your CAS to help you with that. So what I'm going to do is I'm going to pop up the CAS again. I'm going to shrink this down just a little bit. And so the equation that we're looking for is this one here. Using our CAS, take the antidifferential of 4x squared plus 9x minus 3 with respect to x, and I get this lovely thing. Then, and this is the important bit, is I can then go define f of x as being that plus c. I can add my plus c in myself. So when I type in f of x, it spits it out for me with the plus c on it now. So I have manually put the plus c in myself, and I have now defined it. What I can then do is go, well, what is I can then solve my equation by going, well, what is solve f of 2 equals 8 comma c, and it spits out the answer. So I've taken the piece of information that I was given before, f of 2 is 8, used it with my calculator. So I've defined it with the plus c, and then I've used the solve function on my CAS. So remember, you can find solve in Math 1, row 3, column 5. It's right underneath the square root or the nth root section. And you can use that to help you find your C value. And then making sure you answer as a fraction, please, because these use a lot of recurrence. And then you can create the final one, which is exactly what I had before. 4x cubed plus 9x, 4x cubed over 3 plus 9x squared over 2 minus 3x plus c, and c was equal to negative 44 over 3, which is, hey presto, what I already got. All right. So taking a look at question, or at 17E, which is a bunch of anti-differential equations. Some of them are just finding the general form, which is, so when I say general form, that generally means with the plus c still in it. And then the exact formula is when I'm giving you the extra information that you need to solve for c and then create the original equation. All right.